Hey there, this is Seth Juarez with Channel 9, here with Andrew Hall. We're in building 18.
18, that's right.
Fantastic. Tell us what you do.
So I'm the program manager for the VisualStudio debugger.
Oh, fantastic. So we thought we would do a 101 introduction for how the workflow goes for making programs and debugging inside of Visual Studio.
Absolutely.
All right, well, show us what you got.
Yeah, so I think the inspiration here is all of us learn how to program at some point, and there comes a magical moment where you learn that there's such a thing as a breakpoint and stepping. And unfortunately, it's not intuitive, so we need to make sure that we understand that.
You just don't console.writeline everything?
Well, that's what I did for a lot of college.
Me too.
We did a lot of stuff in Linux, so console.writeline was sadly the way to go. C++ and Linux. GDB was not the most friendly thing.
No, it wasn't very friendly, actually.
But yeah, Visual Studio is a great IDE. One of the things that people tell us they like the most about it is the debugging experience that we have. And so I'm going to use C# today, but everything I'm going to show applies to any language Visual Studio supports, whether it's C++, C#, Visual Basic, JavaScript, Python, etc., etc.
Cool.
I'll say the most basic thing in debugging is the concept of a breakpoint. And so what a breakpoint is going to tell the debugger that when an application reaches a certain point in execution, that it's going to stop, and then I can look at the state of the program.
Fantastic. So what is this program doing?
This program is going to eventually calculate the area of a circle or the area of a rectangle, depending on what the user is going to input.
Got it.
So it's not going to do anything yet, but if I click Start Debugging, so there's a couple ways to do that. I can click the Start button up here. I can go Debug, Start Debugging, or I can use the keyboard and just press the F5 key. So I'll go ahead and start debugging, and it's just going to ask me for the name of a shape. So if I type in rectangle, then it should ask me for the height and width and then spit out the dimensions.
Right.
We haven't got that far yet, but that's ultimately what our program is going to
Cool.
do. So first thing I want to make sure is that the shape name is being just input correctly, that I've written this code correctly. So I'm going to use the debugger here to verify. One of the great things the debugger can help you do is actually validate that your application is just executing like you think it is. It doesn't just have to be used to solve bugs, especially when you're first learning to program. A lot of times you're like, oh, I'm going to write some code. Is this going to behave like I think it's going to? Set a breakpoint, make sure, just verify. So I'm going to click Start Debugging. And what's going to happen is after I type the name of this, let's try to spell it correctly, I'm going to hit that, and you can see that it's turned yellow, and I don't see my application executing anymore. And so what's happened is my application is actually not executing. It's paused under the debugger, and I have the ability to inspect the state of my application. So inspecting variable values can be done in a couple ways in the debugger. One of people's favorite ways is if you just hover over the name of a variable, we pop up this little thing that's called a data tip, and that's going to display the value to me right here in the editor.
Cool.
The other option is we have these watch windows down here below. So I have the autos window. That's the default window in a lot of the various profiles that you get, and it's going to try to be smart and show me variables that I'm using in proximity to wherever this little yellow arrow is. It's called my instruction pointer, and this stops right before the line of code that's about to execute.
So that means that line has not been executed yet, but everything before in scope has.
That's correct.
Okay.
So I have not actually run this if line yet.
Okay.
That sometimes is a point that gets people sometimes as well, because one of the things you just have to learn.
Right.
Or
you can watch this video.
Or you can watch this video.
I'm just saying.
And we'll be teaching you.
That's right.
So the other windows that we have locals. Locals shows me all of my local variables. These are variables that only are defined inside the current method that I'm debugging inside of. So you can see here, at the moment I only have a shape name and the arguments that are passed in.
Right.
And then we have the watch that allows me to manually type in anything that I want. Now at the moment I don't have anything else interesting, but I could type in args.length, for example.
And you get IntelliSense in that window.
I get IntelliSense in this window for most languages.
Right.
And so when I enter that, it's going to tell me that there's no arg-length, but I can type anything custom in that I want.
Got it.
If I want to drill into properties or something like that.
Could you put an expression in there?
I could put an expression in there. So let's say shape. So I'm going to look at shape name equals circle. So let's see what happens if I type that in here. And it's going to tell me that that's going to be false.
Cool.
So I can, absolutely do that as well. So I can try things out. Another window that I've closed now, but that can be really convenient for doing that is called the immediate window. So it does the exact same thing, if I can find it on here, as the watch window, but I can do things like, so I can say shape name, IntelliSense again, and let's say I wanted to use this equals instead of let's say rectangle, and I can do that, and it's going to tell me that it's false.
It's kind of like a command line area, but with everything in scope.
Yeah, it's going to ultimately do under the covers the same thing that the watch window is going to do. It's going to pass it to something called the expression evaluator that's provided by any given language that you're debugging. So for example, the C# compiler provides the C# expression evaluator. The VB compiler provides the VB expression evaluator. But yeah, it's just a command window form. And the nice thing about this is you have a nice history of everything that you've evaluated.
Cool. So just to summarize, we have autos, locals, watch, and immediate window. The quick sentence for how they're all different.
Yeah, so autos tries to be smart about what it shows me. Every language can pick its own rules, but basically, if I recall correctly, the general rule of thumb is 1 line behind and like 2 lines back.
Got it.
So any variables that are used within a few lines of where the current instruction pointer is are going to appear here, and whether that's going to be true, whether they're global, class member variables, or local variables.
Got it.
The locals window is going to show me all local variables defined in the current function that I'm debugging.
So anything in scope or just that function?
Any local variable defined in that function.
Got it. Okay.
And so that is kind of scope, but.
So if you have like a class member that's public, will that show up in the locals?
The class member.
So say you have.
No.
Okay. There you go. Okay.
Yep. So it's only, not in scope, just truly local variables to that function. The watch window is my blank canvas to type whatever I want. And the immediate window is a command window to evaluate. And we do hear from a lot of people that one of the things I like about the immediate window, as I said, it leaves now a permanent history of things that I've evaluated. So if I change the value of shape name, for example, so I can actually change values in the debugger as well. So let's make it, say, circle now, for example. Before I do this, let me dump shape name here. So let's evaluate shape name. So it's going to tell me that it was rectangle. Now, if I'm going to paste what I just started to do, I'm going to change it to circle, and I'll try to spell it correctly. So now the value of shape name has changed to circle, and you can see that the watch window is updated. So I have lost history. So if I go over here to my autos, I can see shape name's this. So all of the watch windows are going to only show me the current value of something.
So it turned red. What does that mean?
Red means that it changed.
Okay.
So if you step, the most common time that you'll see it turn red is if you modify something as you're stepping through code, and we haven't quite gotten there yet. But we turn values that have changed red, sort of just help them jump out at you, catch your attention really quickly.
So like if you're in a loop, you'll see the things that are changing constantly.
Correct.
Got it.
But yeah, so going back to the immediate window, I now have a history that tells me that shape name at the point in time that I typed this in was rectangle, whereas that history is actually not preserved over here in the watch windows. The watch windows are kind of a point in time where this is that permanent record. So that can be useful sometimes when you're trying to, type this, type that. Oh, what was the value 3 steps ago or 3 iterations ago? Oh yeah, I still have it up here in my in the immediate window where the watch window doesn't show that information to you.
That's really cool. So this is breakpoints. You click over on the margin of it. You debug by hitting F5. You stop, and then you can look at everything that's going on in the program.
Yeah, absolutely. I don't actually. It's been a little while ago. I don't remember how I set it, but yeah, the most common way with the mouse to set a breakpoint is you just click over here in this little gray margin F9, right here, right? Or F9 is the keyboard shortcut. Yeah, so I can press either one works. Nice. And everybody has their own workflow that they prefer. Some people are keyboard centric. Some people are mouse centric.
Fantastic. So we talked about setting the breakpoints. Is there only one way to set a breakpoint?
Well, we talked about the mouse. We talked about the keyboard. If for some reason you are really inspired or you need to do it via some other thing, you can actually come in here via the debug menu and choose to do that, and it'll set on your
What I mean is can you do more with a breakpoint? Is it just like it'll stop here and that's it?
Oh yeah, great questions. You can do more with a breakpoint. We have these little settings up here. So I can go into my settings and I can choose to set conditions on a breakpoint, for example.
I see.
So I could say I only want to stop if shape name, and I'm going to get my IntelliSense here again, equals, I guess it helps if I actually make it equal to something. Let's pick Seth. That's who you are?
I do have a shape. Sometimes it's round.
So then if we start debugging, I'm going to type rectangle. and we didn't actually hit the breakpoint because that condition wasn't satisfied.
So there's a way to set a conditional breakpoint. Stop here only if this condition applies. Can you nest those conditions, or is it just like one expression for a Boolean expression?
Yeah, so you can nest them. It's going to be conceptually anything you would type inside an if statement. So I could make this compound. I could say or shape name equals Andrew. So I could do that. I could, and basically anything you could do inside an if statement.
There's also an add condition.
There is an add condition. So we have other types of conditions that we support as well. We have a hit count breakpoint. So you can do it based on the number of times that the breakpoint's been hit. So if you're inside a for each loop or something like that, you say, well, I know that the first 10 are succeeding just fine. Instead of, I don't know exactly what the condition is going to be on the 11th one. Let me just set a hit count of type 10. And so if I do hit count, I can then choose, as a multiple of or greater than equal to. So the scenario I just said, okay, I know the first 10 are fine. So let's say if the hit count is greater than or equal to 11, and now I can just keep debugging and it'll be hit every time after